Carbon forms 4 bonds that are arranged in space at the corners of a tetrahedron, giving bond angles of about 109 degrees and making the shape three-dimensional rather than flat. Think of carbon as the center of a tiny three-dimensional pyramid with no base, where each bond points toward a different corner so they stay as far apart as possible. If you imagine standing in the middle of a playground and holding 4 strings that pull outward equally, the strings would spread out into a shape like a pyramid with 4 corners, not a flat cross. This happens because the electron pairs around carbon repel each other and settle into positions that minimize that repulsion, creating equal spacing. Chemists call this arrangement tetrahedral, and it explains why molecules with carbon can have specific three-dimensional shapes that affect how they behave. A common mistake is picturing carbon bonds on a flat page like a plus sign, which hides the three-dimensional nature and can lead to wrong ideas about molecular shape. A quick fix is to draw one bond coming out toward you and another going back away from you to show depth. Another error is thinking all tetrahedral molecules are rigid and cannot change shape, but they can rotate around single bonds. So remember that bonds can swivel even though the tetrahedral geometry at each carbon stays the same. Students also sometimes forget that the tetrahedral angle is not exactly 110 degrees, but about 109 degrees. So say the approximate value to stay accurate. For more videos and resources on tetrahedral geometry and organic chemistry, visit www.gumballdegree.com.